Welcome to the Electricity North West DFES webinar. Throughout the call, all participants will be in a listen-only mode, and afterwards there'll be a question and answer session via the Q&A box on the web console. Just to remind you, this conference call is being recorded. Today, I'm pleased to present Victoria Turnham. Please begin your meeting.
Thanks, Lily. Good morning, everyone. I'm Victoria Turnham, Strategic Planning Manager at Electricity North West. And I'd like to welcome you all to our first webinar on our Distribution Future Electricity Scenarios publication. Before we commence, I'd just like to run through the arrangements for today. The presentation will last around 30 minutes, and there will be a further 30 minutes for question and answers to follow. You can submit your questions during the webinar through the online WebEx chat function, and we'll answer these at the end. The slides used for today's presentation will be available on our website following this event and will be circulated to everyone on who is registered. The Q&A panel at the end of the session will be with myself, Simon Brooke, Christos Kaludis and Jill Williamson. Our inaugural DFES document was published in November 2018. It introduces our forecasting methodology and approach, the 2018 demand and generation forecasts, as well as resultant network impact assessment for this period. Today's session will broadly follow the structure of the document. So we'll explain what we're trying to achieve by sharing information about the North West network and the range of possible electricity futures. We'll also talk about how these forecasts have been developed and the future scenarios, and the need for our stakeholders to get involved, and present to you what may be the impact for these local networks. The objective of today's webinar is to stimulate debate and help inform the decisions that will shape our electricity future in the North West. The North West, as with many areas in the UK, is seeing a significant rise in new technology, and changing customer requirements are transforming the way that we distribute and consume electricity. The key here is we cannot wait to be certain up to what level these changes will project into the future. So we want to promote and sustain the conversation around these changes in the North West with all of its stakeholders. As the North West Regional Network Operator, it is our responsibility to manage now and into the future a safe, reliable and affordable distribution network. We see it is incredibly important that the electricity infrastructure is in place to support local economic development and lead the region into a low-carbon transition. For those of you who are familiar with Manchester city centre, you'll see a skyline full of cranes. This is a really clear indicator of growth and redevelopment in the area and the requirement for electricity to enable this. We need to understand what is possible across the whole of our network so we can plan a network with a range of least regrets investments. As an electricity industry, you may be aware that the transmission and distribution network operators are preparing or commencing the transition to become system operators as well as network owners. This designation ensures that at an industry level there's focus on how we coordinate and run efficient networks while effectively utilising the growing demand and generation and storage across the whole electricity system. For our North West stakeholders and customers, our role at Electricity North West will not change. We will provide the network capacity you need to grow and decarbonise. So as the North West system operator, we will facilitate innovative approaches and flexible methods to deliver the capacity needed. We will aim to create local energy markets that can provide network flexibility services to be used to balance the network in real time. Importantly, we're investing now in data systems and network automation needed to make this happen. But at the centre of this is our capability to look ahead and forecast and assess for the future. In summary, our first DFES aims to describe and make available our views on the range of credible future electricity scenarios. These scenarios are pathways for the future electricity requirements across the North West for the next 30 years. Alongside our future 5 scenarios is a regional network insight for the 4 main geographical network areas. We use these scenarios to help shape our long-term network plans, but we want the DFES to be accessible to all our stakeholders so that they understand the range of future opportunities and challenges associated with electricity in the North West. The information in the publication also serves as a useful long-term indicator to where the network capacity may be constrained, as well as might be opportunity to participate in new flexibility requirements. We're keen to communicate with all our stakeholders, and today is just one way that we're doing this, and we encourage you to get involved with our numerous other stakeholder forums. Before we start looking at the future, today's position in the North West is a really useful baseline. The key here is the 4.4 gigawatts needed in the North West at peak times, and the relatively high level of DG we have connected to the network from a diverse number of sources. The network in the North West, as with across the rest of the country, has evolved from a traditional passive top-to-bottom flow network to one that is becoming increasingly smart and flexible. We need to support a range of customers across our 2.4 million base, from those remote individual customers to large customers with big development plans. So to summarise, we currently distribute 4.4 gigawatts of power at peak times and connect 2 gigawatts of local distributed generation. This does exclude our 132 connections. As you'll see through this presentation, the DFES work is helping us consider how these key metrics may change over the next 30 years and what the impact of the network may be. In an increasingly uncertain world where our future is influenced by many factors, it's important to understand the range of credible outcomes. The 2 key drivers that frame our regional uncertainty is economic development and environmental change. These are our 2 axes on the scenario diagram here. Increased prosperity and/or increased decarbonisation can significantly impact electrical demand. Prosperity may be more money for domestic and industrial and commercial customers, but also investors in the energy sector and local communities. Similarly, there is a strong influence from national and local policy actions which support a green future. An example of this is the increasing government focus not just on the energy sector greenhouse gas reduction, but that of the transport sector too, with the government planning to ban sales of traditional combustion engine vehicles by 2040. This will lead to a significant requirement for grid EV charging. We use 5 scenarios shown here with different underlying assumptions on economic development and environmental change to explore the electricity requirements over time. We don't think the future will be exactly like one of our 5 scenarios, but the creation of them and the resultant forecasts allow us to undertake what-if experiments to assess the implication. Future uncertainties in each of the scenarios lead to a significant difference in the future forecast of electrical demand, generation and storage output and reactive power requirements. As an example of this uncertainty could be the recent release by BEIS of its offshore wind deal, which could see an increase in new Cumbrian coastline generation connections from 2030, but by how much we just don't know. Potential changes to the UK capacity market in light of the recent EU ruling adds uncertainty into how future generation and storage projects across the North West might materialise too. To best understand how a wide range of drivers can impact future forecasts, we need to engage with our stakeholders to increase the certainty of our forecasting process. We engage with national and local authority bodies, local communities and investors so we can understand their development plans and how they may affect our future trends. Our forecasts are developed from our innovative forecasting tool, Atlas, which is unique in that it follows a bottom-up approach building on individual postcode data to reflect supply area trends on a half-hourly basis. This allows us to evaluate the whole electricity system, for example, customer behaviours and interactions, and adjacent networks at both distribution and transmission level. Unlike national grid system operators for future energy scenarios, we focus just on the future of the electricity system in the North West. If we move now to look at our latest forecast results, we will start with the change in peak demand up to 2050. As I mentioned earlier, the current baseline for winter peak demand across the North West is around 4.4 gigawatts. Under every one of our future scenarios, we see significant demand growth. This is between 120 and 180% of the current 2018 baseline. A variety of factors affect our peak demand forecast and the rate of increase. So if we just look a little bit more closely at the graph, in the short term, up to 2028, planned developments dominate the growth. These are specific domestic and industrial and commercial developments as advised by our stakeholders. The level of demand growth directly correlates to the level of GDP growth in each of these scenarios. It is lower in focus on efficiency and slow progression. Average of 1.8% growth per year for active economy and green ambition compared to the 1.3% for slow progression and focus on efficiency. Moving beyond this initial near-term horizon, the demand growth is driven by LCT uptake, with active economy and green ambition forecasting a high level of heat pump growth beyond 2033. These increases are counterbalanced with what we expect to be reductions in electrical consumption due to more efficient buildings and processes and the potential benefits of smart metering. It's worth highlighting that the growth in maximum demand is not consistent or equal across all of our local networks, and therefore we present these regional trends in the regional insights part of this presentation. Very important to acknowledge the projected impact of EVs and heat pumps as key contributors to the future increase in electricity consumption. Electricity networks are essential infrastructure to support the decarbonisation of transport and heating, and we will provide the infrastructure required to achieve this sustainable growth. The greatest uptake of electric vehicles is forecast in 3 of our 5 scenarios, with nearly every customer in our supply area having some form of electric vehicle. We keenly observe how any further changes in regional or national policy, as well as incentives and technological developments may impact the rate and level of change. We've used information coming out of Ofgem's network innovation competition projects, for example, Electric Nation and My Electric Avenue, which are researching the use of electric vehicles to understand what forecast number of EVs may mean in terms of electrical demand. Knowing where and when EVs may be charged is difficult for us to predict, but a range of assumptions are being stress tested to understand what this may mean for grid infrastructure. Now looking at another key decarbonisation technology, the deployment of heat pumps, our green ambition and active economy scenarios predict around 1 million heat pumps by 2050. This is driven by prosperity and government incentives largely. We believe the latter will be a key stimulator for this market. For example, BEIS's recent position to preclude new homes from having gas connections from 2025 could result in more heat pumps being connected to our network quicker than we initially anticipated. Moving now to look at DG forecasts, we can see it will increase from 2.3 gigawatts currently to between 5.5 and 7.9 gigawatts depending on the scenario. Regardless of scenario, it will at least double in the next decade. Set to be quite an abrupt rise in the next 5 years due to flexible generation, which is providing flexible balancing services to the system operator. We're also expecting long-term growth in wind and solar generators as technology improves and costs reduce, meaning that they can efficiently participate in the wholesale electricity market. Energy storage will play a key future role in smart operation of our network, allowing us to balance and efficiently use existing network assets. We've seen the first storage connections to our network, with one of the largest in Europe being Centrica's 49 megawatt development at Roosecote. We're forecasting some industrial and commercial customers will connect behind the meter storage to access efficient charging tariffs and provide system operator services. The anticipated cost competitiveness at domestic level could see some more homes combine PV with storage to reduce their energy consumption. Importantly here, battery charge and discharge could happen at any time. So in the extreme, we could see an additional 1.5 gigawatts of either demand or generation connected to our network as a result of battery storage. And finally, an important area in power systems is the flow of reactive power for system stability. This component of power flows through the network to deliver useful active power to customers. We anticipate a reduced need for reactive power across our network due to the type of appliances we are using and the increase in distributed generation. This is also likely to mean the amount and duration of reactive power flows up to the national grid network will increase. This will lead to voltage regulations on our network, but also on the transmission system too. We have pioneered a reactive power forecasting approach through our Atlas project and have incorporated this already into our planning processes in advance of many other DNOs. The tap changes in our transformers as a result of this change in reactive power may be required to adjust the voltage more than they are capable of to maintain voltage limits. Our work has shown that around 60% of our transformers will need to operate at a higher tap by 2026. We use our electricity forecast to assess how our network will cope in the future and what intervention may be required. This next section of the presentation looks at an impact assessment for the 4 regions across the North West. Our regional insights methodology looks at the primary substations, the joining HV network and associated BSPs under the central outlook scenario. We examine in the DFES document the thermal fault level and reverse power flow, but in this presentation we'll just focus on the thermal impacts. The 4 regions that we have highlighted here have distinguishing characteristics in terms of network and customers, and they've allowed us to effectively identify distinct regional challenges. As part of the DFES, we have not identified specific network solutions, but just highlighted the need for intervention at some point in the future. We will look at reinforcement options nearer to the time, and we always assess a traditional solution against the availability of flexible services. We'll start by looking at our most northerly region, Cumbria. Cumbria has the lowest population but covers 60% of our supply area. It is predominantly rural but has industrial hubs of Barrow, Workington and Sellafield. Much of the supply network for this area can be characterised by long overhead lines, meaning that voltage is often the dominant constraint. Peak demand for the area is currently 720 megawatts, about 15% of the regional total. This could grow by on average by 140% by 2050. The region's high wind resources make it attractive to developers. This has led to the region having the highest ratio of DG to demand of any of the 4 regions. Looking forward, total generation is forecast to exceed the region's maximum demand. We anticipate that this will cause further constraints, particularly at the transmission distribution interface for the area. We are building the enhancements already to our active network management facilities to allow greater flexible connections in this area. All of our grid supply points are currently under the Statement of Work Appendix G trial, giving us monthly updates on the amount of transmission headroom for new generation. And it's worth noting that we're working with National Grid to enable connections in this area, either through reinforcement at the grid supply points or alternative network connection arrangements. So by 2023, we'll see demand growth of up to 150% across the region. These diagrams here show that on a primary and BSP level by 2023, that we will have sufficient capacity to meet the forecast future demand. With the majority of the dark green area, which is networks which are less than 50% loaded. By 2050, we'll see demand growth on average of 140% across the region. At this point, we'll start to see primary capacity issues, mostly concentrated in the south of the area. These are less rural areas fed from Ulverston, Lancaster and Kendal. As these are relatively small, less than 50% overloaded, then there may be opportunity here for us to use flexible services to defer or discount traditional reinforcement. Now looking at BSP capacity, the three southernmost BSPs, Barrow, Kendal and Lancaster, will start to experience overloading between 2040 and 2050. It may be possible to use flexible services to defer reinforcement in this area, or use of active network management and battery storage to manage demand and generation in the area. Given the severity of the overloading at Carlisle BSP, it is anticipated that we'll need to do traditional reinforcement in this area at some point before 2050. Moving now to look at the Lancashire region. It's quite a diverse area in terms of network composition and customer base, with nearly 1 million customers connected here. It feeds the southeast and north and eastern parts of Greater Manchester. There's former mill towns of Blackburn and Darwin, the seaside town of Blackpool, as well as large parts of rural Lancashire. Our forecast predicts significant growth in maximum demand for the region. On average, it will grow by 52% by 2050. It should be noted that there is significant variation across the region, with some areas seeing quadrupling, while some areas small net reductions due to energy efficiency. In Lancashire, we believe there's quite a good mix of rural and brownfield land, making it quite attractive for future DG development. It has historically been an area of low uptake, but we do expect significant future growth by up to 400%, especially as many of the local plans reflect this decarbonisation ambition. We anticipate the main technology type to be flexible generation and rooftop PV. Looking now at primary capacity for the area, our analysis shows that we do not anticipate any overloads in this area by 2023, with the majority of the area less than 50% loaded. However, in the minority of areas shown here in the lighter green, where there can be between 50 to 100% loading of primary assets, there may be localised reinforcement needed to deal with specific developments when they arise. Looking at BSP capacity up to 2023, the only areas that we need to be concerned about are Wigan and Darwin, which are showing relatively small overloads. Our philosophy in these circumstances is to look at adjacent networks to understand whether there is some transfer capability, to maximise installed asset capacity, and also flexibility service options. When we project to 2050 for the area, there is moderate and severe overloading at the primaries, serving the central and southern area. Severity of overloading means that there will inevitably need to be some reinforcement by this point. By 2050, we're expecting BSP overloading across much of the region, and this will form key parts of our future investment plans. Okay, moving now to look at the Manchester area. This is a very customer dense area. Around 25% of our customer base reside here. It covers the very high growth areas of the Central Business District and the Manchester Airport Enterprise Zone. We have commercial and retail customers in the city centre, moving out to residential and industrial areas on the outskirts. Demand growth in the area has significant variation. The average is around 170%, but in some places demand could quadruple by 2050. Led by Greater Manchester Combined Authority, there is a strong decarbonisation plan for the area. As a business, we're supporting the Greater Manchester 5-year environment plan and the area's ambition to be carbon neutral by 2038. The region has low installed DG capacity due to its traditional urban landscape, but we believe there's significant potential for growth here, particularly in the small to medium scale roof mounted PV. Also, the flexible generation and storage market is well placed to utilise current brownfield land. Over the short term, there is extensive economic and regeneration development plan for Manchester. Examples of this is the regeneration of East Manchester, the South Manchester Enterprise Zone and Airport City, and the planned Piccadilly expansion. So looking at primary capacity, by 2023, we know that demand will outstrip capacity based on these known projects. Therefore, we are commencing strategic interventions in these areas to ensure that there is sufficient infrastructure to drive this growth. This growth is also reflected in the need for BSP capacity as well. The upgrade of Stewart Street BSP is being undertaken and its associated demand transfer works, and this will help us alleviate short-term constraints across the area. The moderate overload in the south of the region at Mossnut BSP is an opportunity for us to stimulate and develop a flexible services market in this area. Moving now to look at the region by 2050. The long-term impact assessment shows further worsening of primary and BSP overloading in the city centre and the area surrounding Manchester Airport. This area for us requires significant low regrets investments. We also anticipate significant demand growth in combination with significant economic investment as well as strong decarbonisation plans for the area, and that's the main theme here for Manchester. Our final region for consideration is that of the Peak area. It's the southerlymost area of our network, covering most of our Cheshire and Derbyshire networks. It's a real mix of urban and rural networks, serving nearly 500,000 customers. As with other areas, there's quite a significant variation in peak demand forecasts across the area, averaging out at around 40% of the current baseline. But we are predicting some notable demand reductions, which we believe is due to energy efficiency measures, which are being championed currently by the local enterprise partnerships for the area. There's also growth potential for DG, projected quadrupling in some of the areas. The region actually has the second largest onshore wind farm at Scoutmoor. So by 2023, the area's networks are assessed to be really robust and have sufficient capacity at both primary and BSP level. Looking longer term, up to 2050 for the region, we predict at a primary level some moderate overloads in the areas neighbouring Manchester as the growth effects here sort of spread outwards. Also towards the south of the region in Macclesfield and Buxton, there are moderate and severe overloads projected, which we'll have to address likely through a mix of traditional and flexible arrangements. This southerly constraint in Buxton is mirrored in the 2050 BSP forecast, and will take a holistic view here of solving constraints at both voltage levels. Okay, thank you for listening to the overview of both our forecasting and scenario assessment work and the resultant regional insights. We hope this has been a valuable look into the possible future electricity needs for the North West. The North West has a really vibrant and growing economy, and we continue to see overall growth in local generation and development of technology. Against this backdrop, it's quite difficult for us to accurately predict a single electricity future. So we have developed our first DFES, to show a credible range of futures, which we think reflect the development, decarbonisation and generation decentralisation trends. Again, we value your insights, so please share your views with us. Looking forward, we'll publish our DFES annually alongside other strategic documents which covers effectively the next stage of the process, where we look at specific networks requiring intervention, and we will demonstrate how we assess a range of solutions and determine the most efficient investment for these areas. With all our strategic publications, we want to distill the complexities of our network, seek your input and challenge what we can do so we can evolve our strategic planning and investment approach further. So that's the completion now of the presentation, and I'd like to introduce my colleagues for the Q&A section here to go ahead now.
Thank you. If you do wish to ask a question, please do so by typing in the Q&A box on the webcast console. Please also note there will be a brief survey to answer after the presentation ends. There will now be a brief pause while questions are being registered.
So thank you, Victoria. This is Simon Brook. I'm going to act as the chair for the Q&A panel. So I'm going to read through all the questions that have come in, and then I'm going to hand the question to one of the panel to answer, although I may actually pick some up myself. We've got a couple of questions that have landed already, but please get those questions sent in. We're more than happy to answer anything that you have if it's in our capability across the panel today. The first question we've got is, do you have any thoughts on how the forecasts might change this year and what the influences might be? And I'm going to hand that one to Christos.
Thanks, Simon. I'm Christos Kalidas, Forecasting Manager with Electricity Northwest. So for next year, we should expect the same rationale of scenarios and minor updates in methodologies and tools we use for forecasting. So, but changes that you should expect seeing in next year's forecasts are around reflecting the latest plant developments in terms of connections to our EHV and HV networks, reflect the latest local council plans in terms of housing and employment development, as well as local plans for the electrification of transport and heat. Reflect also latest activity around generation connections across the different parts and voltage levels in our networks, as well as updating our tools using, let's say, also the latest forecast of GDP growth.
Okay, thank you, Christos. So we're going to come to the next question, which is, how can I get in touch to tell you about my plans? And again, sorry, Christos, but this one's going to come to you as well.
Thanks, Simon. So any plans, you can contact us using the following email, development.plans@enw.co.uk, and in particular cases, we would be happy to offer bilateral meetings and further discuss your plans.
Thank you, Christos.
It's just also worth noting that we've got a section on the website detailing all our future stakeholder events. We will send that through with the slides so that you can see where you can get involved over the coming months.
Okay, thank you, Victoria. So let's move to the next question, which is, please can you remind us of the key differences between the different scenarios? And it's probably worth just going back to one of the slides that was previously shown.
I think if we go to slide 6.
Yeah, and sadly, Christos, this one also comes to you as well. So
slide 10. Yes.
Okay.
So, focusing on the differences across these scenarios, as you can see in this slide, the scenarios are our way to frame future uncertainties around demanded generation. So we correlate these uncertainties, the potential future views of the world with prosperity and green future. So practical, focusing on the difference now, an active economy world is a world where there is a lot of prosperity, so we expect that our customers will install more heat pumps, they will use more air conditioning compared to all other scenarios. Green ambition world is a world where we expect more renewables compared to other scenarios, because there is more prosperity and at the same time there is focus on a green future. On the other scenarios, focus on efficiency. As you can see, it's a world that is not as prosperous as the two I've already talked about, but there is a focus on efficiency, so we should still expect some measures on reducing energy demand. And slow progression is, let's say, a world where we expect low prosperity, low focus on green future. So it's a world where we expect to see less plant development materializing, less renewables, heat pumps, and low carbon technologies in general.
I think it's worth, excuse me, Jill Williamson, I think it's worth adding to that the regional insights that we've shown were related to the central outlook, and which means that if we were to look at an alternative scenario, the results would indeed be different. It could be that for something, for instance, slow progression, we might see that the impacts were seen later. However, with more of the ambitious scenarios, such as green ambition and focus on efficiency, the insights that we've shown in these slides today, and including our DFES, may be seen earlier.
Very right.
Thank you to Christos and Gillian. We appear to have run out of questions, so I think I'm going to pause, move just to the last slide, just to remind everyone of where you can find information, how you can contact us, and then just pause for maybe a moment and see if there's any questions, any lingering questions anyone's got and they'd like to send through to us. And we've had a question landed, so thank you very much, and please get all your other questions and the question is, what does the flexibility service include? And it's probably sensible for me to pick that up because that's part of my team's responsibility. When we identify that there is an issue with our network and we look to find a solution to remove that issue, part of the potential set of options is what's called flexibility services, which is where we buy a commercial service from a customer or a set of customers to flex either their generation or their demand, whatever's required, instead of the standard asset intervention solution. So we take a very pragmatic, sensible look at what the options that we have to mitigate any issues that we identify across our network, and we ask, and we have asked for people to provide us flexible services. So Victoria, in her presentation, talked about a number of areas across the network in Greater Manchester. She mentioned the work that we're currently doing on Stewart Street. Well, Stewart Street was previously offered as a flexible service. The South Manchester Enterprise Zone around the airport was also offered as a potential flexible service, and we just closed the East Manchester offering for flexibility services as well. So we are quite active, and that is available on our website. Please go and have a look at it. If you go to our website and just click in to search on search facility flexible services, you'll find it straight away on our webpage. We have another question, and the question is, to what extent is account taken of the potential impacts from technology breakthroughs or technology disruptors? So I'm going to hand this question to Christos, who will hopefully give a bit more explanation of some of the underlying assumptions that we make as far as technology is concerned.
Yes, so as I described earlier on the scenarios are, we follow the two axes that are around prosperity and green future. So there isn't an axis around uncertainties around technological, let's say, advancement and things like that. So our scenarios take into account any advances in technologies as related, let's say, to how these are correlated with future worlds in terms of prosperity and green future. So, for example, technology, talking about technology, as Victoria mentioned in her presentation, it's the low carbon technologies that we try to correlate in these scenarios using these axes. So we are talking about heat pumps, air conditioning, e-vehicles when it comes to demand. So it's also an example is also PV parity technology costs that decrease over time.
So just let me back Christos up on that point. So we have a thorough view of what technology breakthroughs are likely to happen as part of our standard horizon scanning exercise that we do on an annual basis, where we understand what the current innovations are or potential disruptors are and what the prices would be. So we not only in our forecasts do a sensible look forward about what the technologies are likely to land and have an influence on demand and or generation, but we're also following what the costs are likely over time as technologies move from simple innovation into actually business as usual. So everyone will know that the cost of storage has dropped quite considerably in the last decade and is forecast to drop going forward as well. But there are new technologies that we are following that are likely potentially to have a bit of a disruptive effect because their ability to be brought forward to market at a cheap cost is a potential that we are looking at.
It's all around. I mean, this is a part of a wider discussion around uncertainties. So we try to focus on the likelihood of seeing these technologies. So part of our methodologies is also consumer choice modeling. So we try to understand how consumers will react with signals of reduced capital costs for new technologies or new policies in place that will incentivize some of them.
Okay, great. Thanks, Christos. I've got another question. Does ENW coordinate available network capacity with third-party connection of rapid EV charging points to avoid future network reinforcement, as with heat maps for DG? For that one, I'll pass to Gillian, who is the custodian of our heat maps.
Thanks, Simon. I think the important thing here is that the heat maps also look at demand. We have available on the website a heat mapping tool, and this mapping tool has got the facility to look at different types of connections. So that covers demand as well as generation and different types of security for those connections as well. So indeed, we are giving guidance on that. We're also looking to collaborate with people wanting to provide flexible services, including any EV charging. So I would suggest that the heat map tool is definitely a good initial insight to what we can accommodate with rapid EV charging. However, it is an initial indication. Very much we're looking to be a facilitator for decarbonisation, and happy to discuss any specific or general inquiries about EV charging. So please don't take the indication of the heat map tool to be the final answer. We'll definitely be able to connect these rapid chargers.
Excellent. Thank you, Gillian. Don't seem to have any more questions in the list. Again, I'll just refer you to the slide that is on the screen now about how you can contact us. I will make a reminder that if you wish to be notified of any future DFES webinars or events, please sign up to our distribution list. That's specifically designed for people who want to follow the work that we're doing either on the DFES or the regional insights. And all of those available ways of contacting or following us are available on the screen. So I'll take one last breath, hoping that someone has a final question. But if not, I'd like to say thank you very much for listening. It's been a pleasure, and if you have any questions, then you have all the details to contact us in the future.
Thank you. This now concludes our conference call. Thank you all for attending. You may now disconnect your lines.